This is one of 3 breakout sessions. Of course, it is the best session, so you picked the right spot. We've got 5 terrific people here with 5 terrific different topics. And of course, the overall topic is emerging and enabling technologies. They're each going to give a short presentation, introduction of what they're doing. And then we're going to open it up. It's all about you guys, questions and so forth. I'm Mark Senti, President of Advanced Magnet Lab. And you can see our guests up here. So we're going to get started right away, and we'll start right out over here with Mike. Yeah, roll or click.
Okay, my name is Mike Duden. I'm with Nscript. Nscript's a capital equipment manufacturer of direct print technologies. One of the key areas that we have been focusing on is moving into the 3D world. My background, I spent a number of years at Harris Corporation. I was the chief technologist for microsystems. So my role in life there was to care about SWaP, which is size, weight, and power for systems, and how do you achieve that. And all of it really drives energy in the system, in the ways you do your packaging, in the ways you do cooling, and so forth. And so, being an electronic packaging guy, if you look at a traditional system, if you look at, just use satellites for example, if you deconstruct one of the systems, I mean, it's a hierarchy of packaging. It's where you take silicon die, those get packaged into its next level of packaging, and then mounted on printed wiring boards, and then into a chassis. And all of that takes a lot of labor, and also in terms of reliability, it's a lot of interfaces that you have to deal with as you go through the manufacturing of these. And so it becomes very expensive, very labor intensive. A lot of the manufacturing processes become subtractive types of processes. So there's a lot of chemistries that you have to deal with. That's why a lot of printed wiring boards manufacturers have gone overseas, because they have environmental issues that they have to deal with all the waste chemistries. So what you end up with is, as you build these systems, and it doesn't matter if it's an iPhone or a satellite, it's a lot of layering of packaging and a lot of materials. And again, the things that we cared about from a system point of view is size, weight, and power. So one of the areas that I had investigated is printed electronics. How do you look at roll-to-roll processing and be able to make electronics in basically a newspaper type process? And the other part of this is really looking at the additive manufacturing world. And so there's a lot of different processes out there. If you look at the additive manufacturing, that was really born out of fabricating mechanical models. So if you're developing a new product, and you want to look at the size and the form and fit of the product, you basically made mechanical models. Originally it was machining, CNC types of things, and then you moved into additive manufacturing using stereolithography or fused deposition modeling, those kinds of things. Basically building up 3D structures using plastics. And then you look at other technologies like E-beam, where you're taking metal powders and then laying level metal powders and being able to use E-beam to build 3-dimensional structures. So what we've been working is really looking at how do you take all of these processes and merge it into a single type of machine, so that the future is that you are able to design in the digital world and then fabricate from the digital information. And so what that offers you is some unique ways of fabrication, unique ways of designing, and probably products that have never been invented yet. Because what you're really looking at is being able to fabricate things that you're not able to fabricate today. In the additive manufacturing world, they've been focused on structure, basically structural things. What we have been doing is trying to merge technology so that you have a structure that you can embed the electronics. So, and we have at our booth examples, but what you do is you basically take a structure and are able to fabricate the electronics and build up that way. We were at the Defense Manufacturing Conference at Las Vegas, and what we did was make three-dimensional dice for the show, but essentially what it has embedded in it is accelerometers that, so when you roll it flash and then light up in the direction that you land. So where we view the world is personalized electronics, so that what we believe is you can enable the mom and pop shops to be able to fabricate things that are local to the region, rather than building manufacturing overseas and shipping in product. A lot of the small businesses would be enabled to manufacture to the local region. So again, what we envision is personalized electronics. So earlier there was a discussion about the iPhone being personalized to you. And personalized is basically what cover that you have, and in my case, I personalized with the curve on the road for the front part of it. But again, you're really personalized to yourself. So if you have the ability at some point in the future to go into a shop and say, I want this car to look like this, and then you hit print, and then it fabricates the car or the iPhone or whatever electronics. That makes things very interesting. That also makes it very local to the market. So that's kind of the vision that we are looking at. Some of the applications that we've been working at, CubeSat is a particularly interesting application because it is a space type of application and pushes the envelope in high reliability. So we have been working with the Air Force and NASA and those kinds of things of building up electronics. So when you build a traditional electronic module, you basically will buy a circuit board that's made somewhere else, buy parts, and then it gets assembled. And what we're looking at and what we have done is you build the circuit board within the machine itself. So you basically go from a design and then build ground up. So you don't start with the substrate, although we can print on most any type of substrates. The goal is you go from a digital file to fabrication. So the analogy is if you have an office printer and you're printing pages, the machine itself doesn't care what's on that page, it just prints pages. It's rated at a page per minute, so many pages per minute. So our vision is to do high volume manufacturing in quantity of one, and what that means is that it's like a digital cube that you can fabricate because you basically boil down the functionality in constituent materials, and so you can do multiple material printing and then be able to fabricate again ground up. So we believe from an emerging technology point of view that we believe that's the future of electronic packaging. So if you take a mouse like this, you're not building separate parts and assembling it. You basically would print this from the ground up. And then, so that offers some pretty interesting technologies that enable you to be very power efficient because you're doing efficient packaging. And also, you can do interesting things like very novel thermal management types of things. Again, at a system level, you worry about the power. So again, there's a lot of interesting things that you can apply here. And so, again, we're looking at, rather than taking an assembly process, we're looking at doing a full-up 3D print process. The other thing I wanted to kind of talk about a little bit is I'm the executive vice president of executive council vice president of IMAP, which is the International Microelectronics and Packaging Society. And we have been looking at a venue for doing a workshop in Florida and being somewhat we were looking at energy from a packaging point of view, whether it's energy harvesting, energy storage, solar, those kinds of things, but for basically mobile type of applications. And so I certainly would like to offer our organization to maybe look at how we might be able to do a workshop together, but again, from the electronics point of view. And this is one workshop that we're running out of El Paso, which that one's focused on 3D.
All right, very good. Thank you, Mike. Is there maybe one pressing question? Otherwise, we'll save the questions to the end. So don't, if you're like me, my memory's only good for about 5 minutes, so better write it down.
Get it out.
Go ahead and click it, Frank. So next is my pristine colleague here from the Advanced Magnet Lab, who heads up all of our energy efforts. So exciting to have Vernon present on superconductivity as an emerging technology.
Very good. Thanks, Mark. Thank you for everybody for being here. This is certainly a jam-packed session. Hopefully we'll give you some good information to take with you and catalyze activities here in the Space Coast and beyond. What I wanted to talk about is one of our key elements at Advanced Magnet Lab is the applications and use of superconductivity. Real quick about the company, our business is really in doing very unique magnet designs. All of our activities and products are mostly based on unique magnet designs in application areas where we feel there is a large and good value proposition. We're currently working in energy, we've done work in medical, and actually spend quite a bit of time in fundamental research as well, working with national laboratories and supporting their activities in terms of discovering new materials or new properties of materials using magnets. So that's our core business. The company has been around for a while, founded in '95, but in the early years, most of our activities have been doing DOE and DOD work, and cutting our teeth on very challenging and difficult magnet applications. 2008, we decided, hey, there are really commercial applications for this emerging technology. So we launched the commercialization plan, attracted investment capital, and since then have been working and really trying to enter the markets that I mentioned above. Our staff is really consists of world experts in superconductivity, magnet systems, and we have a very good legacy of automated manufacturing as well. Just for those of you who are not familiar with superconductors, just a few minutes on what they are and what the implications are. Superconductors are really electrical conductors, like a wire, but they have zero electrical resistance when you cool them below a certain temperature. There are different kinds of superconductors. You might have heard of high temperature superconductors, low temperature conductors. Basically, as you reduce the temperature, the resistivity, this mouse is not that responsive, but the resistivity reduces and eventually goes down to zero. So what are the implications of that? Well, basically it means that now instead of needing a huge copper cable to carry current or electricity, you could get away with a very small, very thin conductor, which can now carry a huge amount of power. So, lighter, cheaper, smaller, all of those attributes come to mind. Additive processes, such that the previous speaker talked about, maybe embedding superconductors in these types of devices could bring huge breakthroughs. Instead of needing large copper buses or backplanes, you could have superconducting traces and circuit boards that can carry 100 times more power than before. So the implications of superconductivity are very significant. Mark showed this chart this morning. Maybe some of you that were in the meeting this morning saw this. I just wanted to spend a couple minutes on this just to share with you really how fundamental superconductivity could change our whole landscape of electronics, electrical products, and magnets. If you really look at the power plants, superconducting generators are more efficient, they're smaller. Superconductors can be used for power transmission. You can transmit a lot more power over much smaller conductors or cables. Substations can use superconductors for energy storage, transformers that connect power to our residential areas. Factories could use superconducting motors that are 99% efficient. That's huge. I mean, if you really consider the fact that over a third of the power in the U.S. is consumed by large electrical motors, if you could make them 5% more efficient, that's a huge savings of power. So again, I don't want to go into too much detail, but you get the picture. Superconductors could affect virtually every sector of power generation, transmission, and power use. I'll get into some more detail about the areas that we're working in right now. But specifically, offshore wind and superconducting generators there are possible, as well as superconducting power distribution inside of facilities that use a lot of power. I'll talk some more about that. One other area, or a couple other areas that are interesting, is space travel. If you could use superconductors for new propulsion methods, also shielding, a lot of the space habitats that are planned for the future require shielding. Using superconductors, we could use a lot less wire and create much lighter structures for shielding those particular habitats that can be launched, in launch vehicles that can handle, that weigh a lot less. So, again, a number of different applications there as well. So if you really want to consider that as an emerging technology, I think there are a few emerging technologies that really touch on so many areas as superconductivity. Now, specifically, the areas that we're working in, I'll talk about two of them in some detail. The first one is superconducting generators for wind. We've talked this morning, Dr. Cheryl from RBE talked about, wind and solar and a lot of other areas where, the growth in alternative energy is very significant and important for, the world in general. Wind has seen tremendous amount of growth onshore. The next generation of wind turbines is going offshore. With offshore wind, we can build wind farms closer to the use centers, closer to where the population lives, which is close to the coast. And the trend there is to build bigger and bigger wind turbines. Currently, in Europe, China, wind turbines are going in the ocean that are about 5 or 6 megawatts in size. But really, the value proposition becomes more attractive as you can make these turbines bigger. You spend less on the infrastructure. If you can put a 10 megawatt turbine in the water instead of a 5, perhaps the cost of the foundation might be 20% more, but you're generating double the power. So it makes sense that size, making bigger turbines is going to improve your cost of energy. However, current technologies that are being used, such as permanent magnet generators in these wind turbines, if you scale it up to the 10 megawatt size, would be too big and too bulky to have in these wind turbines. The foundations would have to be too big. So new technologies are required that can produce generators that go into wind turbines that are smaller, lighter, more efficient. And so we're currently funded by the Department of Energy to do a full design of a generator for wind turbines, for large offshore wind turbines that are smaller, lighter, and basically have the potential to meet the cost of energy targets, which will allow offshore wind to be competitive with other forms of power generation. So that's a very exciting project. Specific to our technology at AML is the design of the magnet coils, superconducting magnet coils that go inside of the wind turbine using superconductors embedded in composite structures. So there's quite a bit of IP associated with that. Another interesting area where we're doing, again, talk about commercial applications. This is certainly not a near-term commercial application, but still, very important for the development of space travel, and actually living out in space. And that's the development of superconducting coils for shielding of space habitats and spacecraft. So we are actually using some very unique magnet and coil technology that we have, along with some very specialized software that was developed over those years where we did a lot of DOE and DoD contracts. And we're applying that to designing lightweight, deployable shielding technologies for spacecraft. And we're working very closely with NASA on these activities. Again, not necessarily something that is a huge commercial market, but nonetheless very, very critical for space exploration. And we're very excited to be working in this area. But again, the common denominator, superconductors. How do you implement them? How do you build coils? How do you cool them so that they operate in your superconducting region? Last area I want to talk about is power distribution. Specifically, data centers, are here. They're growing. There are many drivers that have, basically caused our society to need a lot of data storage and data processing. With the growth from 3G to 4G on cell phones, the amount of data, the amount of processing, the amount of storage is just going to continue to grow exponentially. Now, to process that information and to store it, you need very large data centers. Today, data centers consume about 3% of the total power generated in the United States. It doesn't sound like a big number, but it is actually very significant. And considering the fact that it's growing, this will continue to be a very large consumer of power in the U.S. Unfortunately, the distribution systems of how to distribute power within the data centers are not very efficient. They're based on large copper cables. These data centers consume a lot of power. Some of them, as many as a couple hundred megawatts. So the power networks inside of these data centers are not efficient. They warm up. If you run current through copper, you have resistance. That resistance exhibits itself, and the losses exhibit themselves in terms of heat. You got to remove that heat from the facility, so they're not very efficient consumers of energy. However, by using superconductors, we're able to design distribution networks that are smaller, lighter, more efficient, and also very scalable. As the data center grows, we can add more networks. The incremental cost of adding additional power is actually less than copper. The initial cost, the fixed cost part is higher, but then once you scale the facility, adding incremental power is more effective, because of the lower incremental cost of the superconductor. So this is a great example of an area where emerging technologies of using superconductors in applications will have very significant impact in terms of overall power consumption in the world. So, again, just to conclude, putting it in perspective, 10 megawatt generators, like we're designing, produce enough power each for over 3,000 homes. So that's again, very significant impact on society, but again, enabled by emerging technology of superconductors. The picture on the right shows a 300 megawatt data center. This is not a data center in existence today, but here's where you can see containers actually containing a number of racks with servers in them. A 300 megawatt data center would contain about 1 million servers. This is the future. This is what our digital society is driving to, and these guys are going to be large consumers of power. But unfortunately, with power distribution systems that were designed a century ago or close to that, so superconductors certainly have the ability to have a huge impact in terms of efficiency for those applications. Now, how do we, since superconductors have been around, they've been discovered over 100 years ago, you may ask yourself, well, why isn't it used? Why aren't these used everywhere? There are applications such as MRI, where superconductors are really the enabler for that technology. MRI magnets are superconducting magnets. But other applications is really about cost, getting the cost of the cryogenic cooling, cost of the conductor itself, to match and to mature, and the risk really to be manageable such that those technologies, implementation of superconductors in those systems can compete with existing technologies today. And that's really the mission that we're on. We're actually funded federally and privately to really work towards that commercialization. But, as with any project, for example, if you look at this superconductor generator project that we're working on, it's really a collaboration of many different technologies that have to come together to enable this kind of machine. When you implement machines with superconductors, since the conductors are so small, it's a benefit, but the negative is that the power density that you have in such small cross-sections is very high. So we need to look at new materials to support those conductors in the structures that they're mounted in, new cooling methods. So, again, it's emerging technologies rely, even though fundamentally it's a very interesting and a technology that has a broad impact, but they rely on other areas and other technologies to grow along with it to be able to implement it in a commercial fashion. And really our quest has always been to continue to bring in investment so that we can apply people to take those technologies and commercial applications. So that's really what I wanted to share with you today. I certainly would love to entertain and ask some questions.
All right, next up is Felix Lavada, Business Development Manager for National Solar Power.
Okay, I have only few graphs here. I'm just here to introduce National Solar to you. We're a 2-year-old company. We started by James Scribner and John Browden right here in Melbourne. And so I'm just going to try to be very simple for this. Our business is utility scale solar. So I guess that's an emergence in itself in terms of technology. But we do need, now that the solar cells themselves and the solar panels are coming down in price, the next parts of the balance of system, if you would be the inverters, which require a lot of electronics and a lot of smarts, and the racking systems themselves. But the inverters really right now are probably the main ones in terms of cost and reliability. Right now, many of the inverters rely on capacitors, and that's probably the only thing that prevents them from going beyond the 10-year life that they're being guaranteed right now. So our goal is to make efficient power plants, financeable, efficient, financeable solar power plants that we would operate. Actually, we have a contract with Enso Phelps, which is is probably the biggest employee-owned construction company in the U.S., and they're out here. And I'm not sure if there's anyone from Hensel Phelps here right now, but anyway, they are in the floor. And so we have a contract with them to install large numbers of panels, of course, in farms. So we are humble farmers, if you will, in a way. But not the old kind of farmer, right? But anyway, so we have quite a lot of experience. Our founders themselves have more than 30 years of experience in the solar business. I started myself in solar and worked in similar areas in the industry. And we have, with utility scale, what you want to do is get a contract with the utilities. All the utilities in the United States, especially here in Florida, are supervised by the Public Services Commission, right? So it's not, just go in there and plug your farm and get the electricity out. So we have PPAs, power purchase agreements in place with Progress Energy and other utilities here in the Southeast to effect this. And it is the fastest growing energy sector, solar is. I don't know how many people have followed solar lately, but it's growing at least at a 40% clip for the last probably 10 years. And we'll probably hit what some people call grid parity, some people call levelized cost of electricity, whatever, in the next 3 to 5 years. It's certainly in many places in the world, it's happening right now. So we want to be the first here in Florida that comes very close, if not at avoiding cost. Okay? We have favorable public and government support. That's what we need to operate. We have to go into communities and become partners. We have to become partners with the utilities. We have to become partners with the economic development commissions and the counties and the government itself and the people in the counties. And we have other partners per se besides Hensel Phelps that I mentioned. We're working with a NAI RealVest, who is a real estate company. They execute our purchase contracts and leases with respect to land. We have a green infrastructure partners, who is part of our financing arm. This is not the run-of-the-mill loans, I guess, that you can get. So it requires a lot of money to put up 20 megawatts of solar. And we have already, like I said, committed partnerships with several communities here in the state, such as Gadsden County and Hart County here in southern Florida. Other than that, basically we're a user. So besides what I said in terms of the inverter, that's what we'd like to see. There's a lot of opportunities, especially for electronics folks here in the Space Coast. If you can, there are some designs for inverters that are out in the public. We can probably take those and add proprietary software, et cetera, but the inverter is what we see right now as the next level. There was one out that's just very recent. I believe that it's a company called Canadian Solar. They're a Chinese company where they're if you look them up, if you look up Canadian Solar, they have a new panel out with an inverter built in. It's a 3-phase inverter that supposedly has a very unique take on how to handle the energy, and so they're providing 3-phase out with very few capacitors, so they're claiming something like 20-year lifetime, so that's the kind of thing that we would like to see. And that's about it on this. I'm here also to answer questions. That's it, that's also.
All right, very good. Thank you, Felix. Excuse me. Next up is Bill Cox, CEO of EDAor Renewable Energy Consortium.
Well, thank you for attending this afternoon. Could we maybe open the doors in the back or something and let some cool air in?
It's getting.
Can we,
We got a heating issue?
I think so, yeah. I think we've got
Need
a
a super
superconducting,
right.
powered up kind of issue. I want to thank everybody for coming today, talk a little bit about my company and why we're happy to be here in Florida. Our little company is basically doing what a lot of other companies are doing right now. So it seems like we're kind of riding a wave. We grow biomass, and then we process that biomass into useful end products. And we're kind of where I think the petrochemical industry is going in this century. And we've already heard about personalization of technology and miniaturization of technology, and we're sort of following that track where instead of billion-dollar and multi-billion-dollar petrochemical complexes, we've got new specialty chemical complexes that can make all kinds of useful compounds and macromolecules, and they can do this at the cost of millions or tens of millions of dollars. So orders of magnitude of reduction in scale. We're here in Florida. The company pilot plant is here. Looks like we'll be putting a laboratory in if things continue to move forward here. We're being pulled in a lot of directions. It's kind of fun and kind of interesting. We are active right now in the Eastern Hemisphere and here in the Western Hemisphere. We just got great relationships, great technology team. I really like being here in Brevard County. I'm not from here. Married a girl from here, and she drugged me here about 2 years ago, and culture shock for me. But anyway, I've enjoyed being here, and there's a lot of great things about the county. People, the ability to hire great staff, it's just really been a good story for us. We discovered the TRDA, and that's just been a great place to grow a business. And if you don't know about that facility over at the airport, at the Melbourne Airport, it's a really great facility and a lot of resources, a lot of things you don't have to buy because they've got the infrastructure and the services, and then also the mentoring. So a lot of good things have come out of TRDA. A lot of really good activities going on at the state level that we're now just beginning to find out about. And it's really interesting how well integrated these activities are. And I've been active in other states and technology companies in Virginia, Texas, Oklahoma, all very sophisticated and bringing technology to market. And I would say that Florida is very competitive on that front. One thing I found being here that's really interesting is we've got a steady stream now of visitors from the other side of the world, literally, and they all like coming to Florida. I never had that happen in Oklahoma. But everybody wants to come, put them down there on the beach. We had one guy from Beijing, and he spent a few days in Orlando with his girlfriend. You know, just really great stories. So being here has been fortuitous, and that everybody wants to come here, everybody. And we had one foreign government tell us that they love the idea that the pilot plant was here because great chance to travel. And they may not have great salaries, but they have unlimited travel budgets. It's been good being here. And just the infrastructure. We have got so many weird requirements for widgets and digits and parts and fabricating. And all those capabilities are here. And we've been able to get a lot of stuff done. We've been working lately with stainless and just getting things drilled, getting things made. It's been great. So I really like Brevard County. And if we haven't found it in Brevard, we found it over in Orange County, Indian River County. It's been really great. What we've done here locally, we've been around for 6 months. We've created 10 jobs. We're getting ready to do another hiring round. We'll probably kick that off in the next month. We'll hire probably about another 10 people. And then this summer, I anticipate another hiring round. I already talked about visitors. All of the money coming into our company today has been foreign direct investment. So for Florida, that's great news. A lot of money coming in, and it keeps coming in, and it's been really interesting. We're being treated very well, very paternally, and so we're growing well here, and we're not having to worry about government contracts or a lot of other things to stay afloat. Texas is really, it keeps popping up again and again and again. We're starting to do more and more things in Texas like it, and we're very active over in the Eastern Hemisphere. Our first project will probably be here in the United States as far as a commercial project. Our second one, if not our first one, will be in Asia, and that deal is being put together right now as we speak. Here in Melbourne, we've got a pilot plant, and we're now looking for space. The county's helping us scout for about 3,000 to 5,000 square feet, the first lab together, where we can have microbiology, chemistry, some of our engineering operations under one roof, away from the pilot plant, which would be a big quality of life improvement. And we've got a whole bunch of projects lining up. So some of the people here will start to spend a lot of time TDY downrange, working in project management roles, maybe spending a year or two overseas getting things put together and commissioned. We are the contract operator for the plants we build. So we don't do a deal unless we stay involved with it. So it's a good business model. Background on us, just so you know about us, we're really organized a lot like an oil and gas company, and a lot of our model, our business model, is taken from the oil and gas industry. That's made us really easy to partner. People that we dealt with, both in the private equity world and in the project world, mostly come out of that industry. And so everybody's kind of talking the same talk and walking the same walk. The other thing we're doing, of course, is biotechnology, and the two come together pretty nicely. And we're basically commercializing, so that's kind of what we're doing. And I think that's the last slide. Anyway, that's it. So glad to be here. Thank you for coming.
All right. Last but not least, and I'm really happy to say that I'm driving that car home tonight.
Yeah, of course.
Gator Orange is Will Nichols with Tesla Motors.
Hey, thank you for having me. My name is Will Nicholas, and I'm the sales manager for Florida and the southeast part of the country. I just moved down to Florida about 9 months ago, and it's been a great place to sell all-electric vehicles. For a bit of background, Tesla Motors is based out in Palo Alto, California. We build all-electric cars. The one that I have out on display is a very orange Florida Gator Roadster, which was our first vehicle that went into production in late 2007, went to market in 2008. We built a limited production, 2,500 of them, to really market and prove our concept of our core competency, which is the lithium-ion battery pack and the all-electric three-phase AC induction motor. So a lot of people ask, why did you start out with this really expensive? Because it starts at $109,000. It's a hand-built carbon fiber sports car. How do you expect to sell a lot of these? We didn't, and this was really to market that electric cars do not have to be slow, ugly, unreliable, but rather they can be fun, fast, sexy, and enjoyable to own. So this was low volume, high price. We're moving into our Model S sedan this summer. It's due to launch to the public in June and July. We have about 8,000 orders for the United States, which pretty much sells out our first 12 months of production. And that's going to be kind of a medium volume, medium price car, starting at $57,000 and going up to about $100,000, depending on what battery pack you choose and how well you equip it. But all our cars are eligible for a $7,500 federal tax credit, which is a great incentive in the United States to own an electric vehicle, knowing that our federal government will kind of credit you back a considerable portion for your effort to kind of transform the industry and the driving environment in which we live in today. So we just announced last week that we're coming out with Model X, which is our crossover SUV platform that's built on the Model S chassis. Received great reviews, being introduced by our CEO Elon Musk, who's actually very invested in the space industry as well. I was staying at the Marriott, and I was like, I'm here with the Energy Space Symposium. And it was late, I didn't get into about 1 o'clock. So she's like, I don't see that here. There's a SpaceX discount, and I was like, yeah, that'll do. Our CEO Elon Musk, after making his personal fortune co-founding PayPal, has co-founded Tesla and is now the CEO and CTO of SpaceX. So a lot of our technology is trying to break out and disrupt what is traditionally known in the automotive space, but now the aerospace industry as well. So I won't speak too much more other than we're trying to build uncompromised electric vehicles that hopefully if you're used to the performance of a BMW or the comfort of a Lexus or the reliability of a Toyota, we hope that you can enjoy and be satisfied with all of those accoutrements in a Tesla and enjoy that it is made here in America and that it is all electric with zero emissions. So if you have any questions, feel free to ask me here or I'll be with the car for the, I would love to test drive everyone. Unfortunately, I'm deprived. I used to drive a Roadster every day. Unfortunately, we've sold out of our Roadster, so there's no more actually for sale. The car that I have outside is privately owned Tim Watkins is a managing partner of Valor Equity Firm, which was an angel round investor for Tesla. And since he has a principal interest in the success of our company throughout the world, and he hired me, he's graciously lent me his Roadster until I have a Model S in April. So for marketing efforts such as these, it certainly helps. Thank you for having me.
We appreciate it. I think at 5 o'clock, you're going to race the vault. Is that it?
Britta's not speaking in another breakout
I
session.
didn't say speed, I said distance. All right.
How much she has in her tank?
Yeah, we'll go there. Before we open up for questions, I think, with emerging technology, it's all exciting, sexy, sounds easy, and I'm sure all these people know it isn't, but just real quickly, what are one or two of the biggest constraints that you either had or have?
Well, I mean, to build something ground up is certainly the maturity materials that are out there. And so we are working with a number of material suppliers, there's strategic relationships like DuPont. And so you're trying to take this desperate, various technologies that have never been integrated into a single system. And so that's always an interesting element to do. But certainly the material technologies out there, there's certain areas, we kind of say we print what we can and place what we can't. So the machine has pick and place capability, so you build up and you place parts too. But ultimately over time, as materials mature, and they will, you start replacing these components that you have to inventory. So in the future, the goal is you have a virtual inventory. I mean, it's just basically breaking that down into elements.
Very good. Vernon?
I think actually similar to what you mentioned, but maybe at a different plane. To bring superconductivity to commercial applications, there are other technologies that need to coexist with that. And the maturity of these different technologies, whether it's cooling technologies, whether it's support structures, composites, electronics, each one of these actually has certain life cycle maturity, states of maturity that they're in as well. And ultimately, to bring a commercial product to the market, all of those need to be mature to get there. So, many times we can configure a particular system, like a generator for winter, based on where all these technologies are today. But that combination doesn't yield a product or a solution that is competitive in today's market. So that's sometimes a challenge. We try to project, where these products that use superconductor are going to enter the market. But it's not just the conductor, it's not just our technology. There are other pieces that have to get there as well. And perhaps the motivation in those other technologies is not as great as ours. So we have to, really collaborate to try to pull these other technologies, forward, so that together we can enter a commercial market. So I think that's one of the challenges. There's other challenges, but one interesting one is that. Well, yeah, I don't want to complain about money, but that's the obvious one. But I figure I pick something that's less obvious. Funding absolutely helps make the world go around. But besides money, there's other things as well.
We can start with money as far as solar is concerned, but we'll end that too. So, well, I mentioned inverters, right? But of course, solar is not going to go much further until you have batteries. And I think batteries are going to get a lot of attention now going forward. And there's going to be, I think there's already a lot of battery conferences announced for this year worldwide. There's one in Europe, I think, in June or sometime. But batteries is, of course, the limiting factor right now. Inverters you like to have cheaper and last longer. So that would be the next one. And those two would be the main.
Very good. Bill?
I don't see a lot of barriers right now in our market, so I think we're okay. Money's always something, it'd be nice to see in the United States a more aggressive, responsive, private equity type of capability. It's certainly there overseas. So that's it.
Will?
Sometimes change is slow, even for very positive, disruptive technologies. And, even though I think that Tesla's a phenomenal product and technological backbone, I think that people are very used to driving internal combustion engine cars, even though they are expensive and they are particularly awesome for our environment or national security, but I think that it'll take a little bit. But I work 7 days a week to try and change that. So.
All right, questions from the audience? Yes, sir.
Yes, superconductor electrical power generation and distribution is definitely a fascinating emerging technology. This question would be, will it burn and fuel? It will. However, such as in material science, the technology available is highly dependent on rare earth elements, such as molybdenum, neodymium, and cobalt. Magnequench was previously owned by General Motors and was bought out by the Chinese in 93, 94, 95. The headquarters is now in Singapore Technology. And we are having a difficult time harvesting and procuring rare earth elements. So as this technology progresses in the United States, has there been some thought for this?
Yeah, a lot of the activities, or not a lot, but some of the activities that we're funded under are actually for replacing rare earth magnets with electromagnets based on superconductors. And in terms of superconductors, we do have choices in terms of what kind of conductors to use. Certain conductors do use some trace amounts of rare earth materials, but there are conductors that use, for example, magnesium and boron, which are widely available. The process of purifying those and actually creating a conductor with it is expensive and needs to be cost reduced and optimized. But in terms of availability of resources or raw materials, there are conductors that are not constrained by that. And that's that's certainly an area where the DOE has a huge interest because of exactly what you're saying. The constraints on rare earth materials and therefore permanent magnets, which are used in electric motors. If those are not available, or if the cost continues to go up, it's going to make electric vehicles, for example, a tough sell.
Can I add to that, though? Monazite, which is the ore that contains rare earths, I mean, it's found in North Carolina. I think it's found in beach sand here in Florida. It's out west. Brazil's got huge reserves of monazite. So the ore, the rare earths themselves are not rare. I understand the problem here in the U.S. has been the environmental constraints with processing the rare earths. And I guess we've got national policy issues on, do we want to have core strategic industries that have a presence in this country, or do we want to allow those to migrate to places where it's easier to work, or where there's maybe less environmental constraints? But that's one industry that I think there's no reason why we couldn't be a world leader. The reservoirs are here. It's just we've chosen not to exploit them, and it's a dumb choice.
But I think the good thing, I agree with that, is that the DOE, as Vernon mentioned, I mean, a significant amount of their funding is going towards replacing rare earth materials through not just superconductors, but nanomaterial development. Not only is that going to yield benefits from a rare earth standpoint, or not using it, it's going to reap benefits for other technologies as well. But that's, I would say, a good majority of ARPA-E's funding that we've seen has gone towards that exact issue.
Are you familiar with the miners here in the States, the mines? There are reports that,
Yes.
yeah, the ones in California, the Mojave, I think it is, that's opening up again, but it's going to take a few years for them to start to move.
Well, there is a company, I believe it's based in Texas, and they're starting to harvest the numbers that, as you had mentioned. And I wondered how well is that progressing? Is it reversing back here in the United States?
But compare that to the curve of the use that's going to be needed. As you look at electrical vehicles come on, there's no way it's going to keep pace. There has to be new technologies developed. John?
Yeah, I had a quick question for Felix that might spur some other conversations here. But, one of the themes that I've heard from different speakers today is that solar cannot be a big energy source. And I personally feel that's incorrect. But I was wondering, from your perspective, now you all are really involved in utility scale solar, what you see the future, assuming that we get storage technologies, because so many people and so much money is chasing that right now. I think we'll get storage technologies that work over time. What do you think the future of solar can be for Florida in particular, as far as the percentage of the portfolio of energy?
I must apologize for not being in the same places that you were to hear this. Can you give me an idea of how big is big? I think solar is big right now, but how big is they talking about?
Well,
Scale.
I think, we heard from Florida Power and Light this morning saying that solar was never going to be a big player in the energy portfolio, and that's why we need to build nuclear.
I think you said 20%, right?
Bigger than 20%? Well, I mean, the thing between, first, I guess I could say a lot of things, but let's start with, since you mentioned nuclear, let's start comparing solar to nuclear. It's an economic issue. The way I see it right now, it's an economic issue. The way that at least the progress numbers have come out, they're already at somewhere north of 20 billion for 2 gigawatts. And now they are getting out of the current contract. Perhaps they'll get into a contract later for build out 2027. I would disagree with that. Florida, first right now, we use the equivalent amount of solar power that you have, outside of batteries. Okay, if you had the batteries or whatever, you would have to install about 120 to 122 gigawatts of solar to have the same capacity that you have right now in all the generators. We have about 50 gigawatts of standby, let's say, and about 20 to 25 gigawatts of that is being used to generate electricity for Florida, year in, year out. Right now, the world is at 57, well, let's say greater than 50 gigawatts worldwide in terms of solar. That's what's being reported from all the numbers that I see. Germany alone, I read that they have like 25, more than 20 gigawatts, about 25 gigawatts installed. That would be about half the world's capacity because they've incentivized it, right? And the prices of the panels are south of $1 a watt. So I think there's a lot of room for solar, even without storage. There's a lot of the inverter companies like Satcon, I believe, they're reporting that we can go 30% solar without batteries because you can have a lot of controls, reactive power. Reactive power, if you're not an electrical engineer, perhaps you can excuse me, but there's something called reactive power that you normally don't care about, but the utilities do, and that affects how the transmissions, the electric power gets to you. So there's a lot that you can do, okay? Why they said 20% only or whatever, it depends on time. I think by 2020 we can be north of that if we wanted to. A lot of this has to do with the way that Germany did it. Now, they also had the money to spend, it's a lot of willpower. But right now with 57 gigawatts generated, and it was in the megawatts in the early 2000s, right? The worldwide megawatts. So it's a silicon. As far as, there are many technologies for solar. There's thin film cat telluride, there's thin film copper indium gallium diselenide, or whatever you call it, SIGGIs. There's thin film silicon. But silicon, for the most part, has been the leader. It's still about 90% of the what's used out there. It's the first technology for the modern solar cell. The solar cell in reality goes back to the 1800s, right? But it was a toy, right? The capacity, the amount of, it was dependent on silicon mainly. That's what I'm trying to say. Wacker Chemie, or Wacker, whatever, however you say it, out of Germany, they're not losing money in solar. They're not be making as much money as they were with the new market the way it is because it's very depressed, But right now, what people have to do is they have to learn more about how cheap solar is. In Florida, people have told me solar doesn't work in Florida, solar is too expensive, etc. Most of them have been, in the industry, of course. But, it's been about the silicon, and the silicon is out there now. Wacker Chemie, all they want to do is chemicals. Okay, they're a very big German company, and they just turned on in October a plant in Germany to create 15,000 metric tons of silicon a year. Their contracts, according to their claims, their contracts are out to 2015, so they may not be making a lot of money, but they're making some money. And they have a plant that's going to go online by, according to them, by 2013 in Tennessee for another 15,000 metric tons a year. So there's going to be plenty of silicon. I said let the market decide. That's what I said.
All right, next question.
Actually, if I could add to this discussion a little bit, maybe address John's question. I guess it depends on whose perspective you look at it from, right? And it's not to say, the stakeholders in the state don't necessarily want it, but from a utility's perspective, yes, they're obligated to provide us with reliable power. So the capacity factor and availability of solar they are probably looking at it from an availability perspective. So they obviously don't want to invest too much into it where there's not a lot of capacity factor, and availability isn't 24/7. But I would argue that solar is more attuned to a more distributed model than the centralized large-scale power plant model. Not to say that that shouldn't be part of the mix. I think that there's a place for that as well. But if you go and look at the Public Service Commission's website with the Commission Navigate Consulting, that report indicated with the available rooftops, I think it was in 2009, there was a capacity of anywhere from 30 to 50 gigawatts of solar capacity on existing rooftops in the state of Florida. And then with a more distributed model than the central scale model, you've got benefits of cheaper or lower line losses, of getting power distributed, where it's being produced, it's being delivered right there. So there's a lot of potential and opportunity, and we're at grid parity now in the state of Florida, depending upon the type of installation on the retail level. It's just that independent producers can't sell on the retail level. They can sell on the wholesale level to the utility. But depending upon the installation, you're at between 10 to 14 cents a kilowatt hour today. So if you're in Progress's territory and in some of the co-ops, the solar is competitive today. It just depends on who's monitoring. And if you look at California's RPS requirements, they were initially at 20%, which they increased to 33%. So there's a real life example there in the current market dynamics that show that it is possible. So I think that it warrants further, serious discussion from a number of different stakeholders.
Let me add one last thing. Since I said 122 gigawatts or whatever would replace all the energy in Florida, so 20% of that would be about 20 gigawatts. So we're far from that. So if they want to do 20 gigawatts, that's fine.
Yeah.
So the solution is emerging technologies to bring the cost down for all of these. I mean, you brought up the Navigant study, that's a great point. And as a company that's looked at wind, when we saw that report, we about fell over because Governor Christ was going around telling everybody in the state there's no wind in Florida. And if you look at the renewable assets of Florida, he's absolutely right if you look on land. If you look at that report, the amount of offshore wind is equivalent to the amount of solar, which you're right, is tremendous. So as a state, any state, you first need to look at the renewable assets and see what you have, and then figure out what that pie will end up looking like the next 10, 20 years. Unfortunately, we have legislators that are responsible for doing that, which have, well, I won't go there. Any more questions, but related more to the emerging technologies? We're not going to solve the debate over solar or wind, et cetera. Yes, sir.
Quick question for Will. And with your cars, or all the electric cars, they kind of focus on what you're going to save miles per gallon. There's another thing that I was worrying about. They're not going to need a lot of the auto parts that they now have. They finally do make that transition. No need for fuel injection, exhaust manifolds, mechanics to do any of that. When it's all said and done, how's that going to affect our economy as far as jobs? Are we going to need the same amount, or are those types of things going to be eliminated? Or is the electric car going to be a lot less maintenance for the consumer?
Sure. It's a good point. We are very much different than a traditional OEM and dealership network. There is typically less associated maintenance with an electric vehicle because there's less replaceable parts, such as oil, mufflers, transmission fluid, air filters, spark plugs. There isn't any of that. So there will be, where there's a lack of, kind of vocational technician jobs, hopefully there will be an increase in the amount of jobs where we need kind of more sophisticated technicians to take care of the software that's developed in our technology. It's a much more complicated setup, or just a more foreign setup with our batteries and our electronic controllers than there is in moving parts. So I hope that the transition from maybe mechanical engineers to electrical engineers could bridge that gap in any type of worker loss. But I will say that we're building our cars here in America, and a lot of the cars that drive here in America are built elsewhere. And I hope that we are creating opportunities not only on the manufacturing and the service side, but also on the changing infrastructure that will inevitably have to adapt. So instead of fill-up stations with petrol or fuel, will rather be charging stations. They can transform some of the energy that these gentlemen are talking about, particularly with solar and offshore wind, into producing electricity that can go into our vehicles.
You spoke about the need to find other technologies to bundle with your technology. So I'm just curious where you go to find the sources of technology, and then how do you market your sources of technology to other companies that might be interested?
Google it.
Space Coast Energy Consortium.
Sorry, Linda, go ahead.
Well, we do a number of collaborations with universities, whether it's UCF or University of South Florida, and we have a machine up at the University of Florida, Gainesville. So, certainly there's a lot of seeds of technology in the university domain, particularly in material technologies. And so we're always looking at where these materials are being developed and how we can strategically align to that and how that can be applied into the types of products we would ultimately want to build.
Right, so follow-up question. Do you have breakfast with the researchers? Do you go online and look for patents? How do you actually build those networks?
I can do all the above, but I mean, we like DARPA. We play in the DARPA rules. And we have a number of universities that we team with, and sort of go to the workshops and places like this, and so networking becomes very important. But when I was at Harris, I would always go out and see what are all the SBIRs being funded, right? And so that kind of tells you all the seed money that's going out there that like we do a lot of DoD systems. What does the DoD care about? And so they're seeding technologies, and so how do we go out and then align ourselves? And so it's no different with Nscript or what we're doing there, because certainly we do applications. So we fit in the solar space. So we're doing metals, the solar collectors on the solar panels themselves, as well as in the bio world, where it's dosing of medicine, those kinds of things. Because while we are handling materials, and how do you put those materials down and control that?
I would say that I think a lot of relationship building, and regardless of what business you're in, it's all about relationships at the end of the day, getting a deal done. You've got to have a travel budget, you've got to be able to get on an airplane, and you've got to be very good at traveling. So I think that that's a very important part of the equation. I don't know if that answers what you're asking, but if you're building a company, you need to have a travel budget. And staying power. And I can think of 3 companies ago, I had a contract that was waiting on, and a prime minister of a foreign country had to sign a contract. And I went to his office every day for 6 weeks, every single day, and sat in there until 8 or 9 o'clock at night. And they finally run me off. But he was trapped. He couldn't leave until I left. And finally, on the 4th of July, he signed my document. It was 6 weeks, and I had to be able to stay in that hotel for 6 weeks. He kept thinking my credit card would max out, and it didn't.
Yeah, it's a great question, and it really happens again at different layers. For some of the things that we do, we get involved with very, very fundamental technologies in terms of materials or processes. And a lot of those, we find them at conferences. We're pretty active on the conference circuit. Some of our scientists do a lot of speaking at conferences. That's a double-edged sword. Sometimes you don't want your technology to go out there, so we always, our management team reviews papers and presentations, pretty diligently to make sure that we don't necessarily leak everything out. But it's a give and take. You can't expect to, guard everything and then learn from everybody else. So we participate in conferences. A lot of those, again, allow us to interact with other scientists, either national labs or other companies at a very fundamental technology level. Then we do trade shows. Trade shows, you have a little bit more mature implementations of technologies or systems that we would integrate with our systems, to again, ultimately deliver an end solution. And then working with the national laboratories, we have pretty good collaboration with them. They are usually involved in quite a few different things that overlap areas of need. So it's ad hoc. I mean, it's as needed, but through our involvement in the industry in general, we touch on that. But it's not necessarily a concerted, organized activity. So.
One more question in the back there.
I just have a quick comment. This is the emergent tech for Florida, and I think often ocean current is overlooked for Florida. We have the Gulf Stream running on the East Coast, and there is a lot of activity. I know FAU just received the National Oceanic, I forget the whole deal, and there are some companies working in that, so it's probably a big opportunity for Brevard County being fairly closely located.
Right, we have a couple of companies in this county, and of course, I know a group down in FAU. I think from a renewable energy standpoint, I know this is so simple, but I think it gets so overlooked, is that efficiency means absolutely nothing. The cost of the energy, the wind blows every day, the sun comes most every day, right? And for those types of sustainable energy, the cost of the energy is free. So efficiency means nothing. It's the ability to build something, whether it's a turbine in the ocean or a wing in the ocean, or a turbine above the ocean or on land or a solar panel, to be able to convert that free energy into something that's going to be cost effective. I mean, for the DOE in terms of offshore to get to what, ultimately 7 cents per kilowatt hour, that's going to be a challenge. But at the end of the day, it's not efficiency. It's building something that the cost to build it, install it, and maintain it, and transmit it is going to meet those energy goals. And in terms of a lot of these technologies, I've had 3 people here come here today. We have a person coming in tomorrow at our facility. I think I get 2 or 3 emails a week of people that have brilliant ideas. And at the end of the day, a lot of these are really good ideas. They probably work, but will they meet the cost of energy equation? That's the real question. I guess we're done. Very good.